All right, welcome to 9.4. Today we're going to define arithmetic series and find their sums. It's day 2. And congrats, you get the formula today. So here is the sum of a finite arithmetic series. I want to point out the fact that it has to be finite. It has to have a beginning and an end. If it's infinite, this does not work. Okay. X is the number of terms. A1, that's our starting value, right? That hasn't changed. And this is our final value. Okay, so the first number plus the last number. Now, it's written this way. I actually prefer to write it this way. Our number of terms times our initial value plus our final value all over 2. I prefer to put it all over 2. This is what I like. If you like the other way, by all means, please use it. Okay? All right, so what is the sum of the finite arithmetic series? Well, if we have our series notation that we just learned, it starts off with the number of terms, and it's all over 2. Now, do we know our initial value? Yes, we do, 14. I'm just plugging numbers into where they go in the formula. Do I know our last value? Yes, we do, 116. But I have no idea the number of terms. Okay, in order to do that, I need to figure out what term 116 is. So we're going to use our explicit formula from the sequences. Our common difference is 3. Okay, so it's going to be 3 and then x minus 1 plus our initial value is 14. Okay, now we're going to plug in 116 in here, and we're going to see what we get for x. We're trying to find what number term 116 is. So 116 equals 3 and then x minus 1 plus 14. Okay, I'm going to recommend for today, I'm going to recommend that we start off by distributing. Okay, and it's just, you could subtract 14 first and then divide by 3 and then add 1. You can do it that way. I'm going to suggest we distribute first, and you'll see why in a little bit. It might ultimately save us some time. So I distribute, oops, I made a mistake. We distribute our 3 to the x and to the negative 1. Now we need to combine like terms. So 3x plus 11. Okay, now we can go ahead and subtract. And that gets us 105 equals 3x. And we divide by 3, and we find out that x is the 35th term in the sequence. Well, that's just what I needed. I needed to know that it was the 35th term so I can put it into my equation. And now I need to find the sum. So the sum, let's see, 35 times, what is that, 130 divided by 2. Okay, well, calculator time. 35 times 130 divided by 2 gives me 2,275. And so if I were to add up all of those terms, I would get that big number. Okay. Now we're setting up chairs. There's 30 rows of seats in a large arena. The first row contains 10 seats, and then each row after that increases by 3 seats. And we need to figure out how many seats are in the last row, and also how many seats are there in all. Well, I'm going to start off with my total. Okay. I'm going to plug in what I know into my equation. Do I know my total number of terms? Yes, I do. There's 30 rows, so I know that my total number is 30. Now, how many are in the first row? 10. My initial value is 10. But I don't know how many chairs are in the 30th row, right? And so that's the number I have to work to fill in. Okay, so we're going to make our explicit formula here. Our common difference is 3 because it goes up by 3 seats every row. And then plus, we start out with 10. Okay, and we're going to figure it out for the 30th term. So a sub 30, I'm going to plug in 30 minus 1 is 29. Okay, 29 times 3 plus 10 gets me 97 chairs. So I guess the first part to the question, how many seats are in the last row? 97 in the last row. Okay, now I know the last number in my sequence, and so I'm going to plug 97 in here, and I solve 30 times 107 divided by 2. 30 times 107 divided by 2. So in total, we have 1,605 seats. That's a big arena. I guess not so big if it's an arena, but if it's an auditorium. Okay, now summation notation. You've been waiting for this moment. You've been hounding me. What in the world is this big E thing about? It's called sigma. It's the Greek letter sigma. And it's just a Greek letter. No need to get all concerned about it. It's just a letter we borrowed from the Greeks. If you remember geometry, you worked with theta when you were talking about trigonometry, right? It's just another one of their letters. All right. The start term goes on the bottom, and how many terms in total, the end term goes on top. Typically, this bottom number will be 1. There are times where it won't be, but for the most part, it'll be 1. And then this is however many terms we have in our sequence. Then we need an explicit equation. This is our explicit formula that has been solved, simplified a little bit. Remember how here I told you that it might be better to distribute, and we got it down to 3x plus 11. The reason why is because that's going to go here. Okay, we're not going to want to leave our explicit formula like this. Okay, so we want to actually get it simplified down a little bit. So we're going to try to figure out summation notation. Okay, we start at the first term. So x equals 1 down below sigma. Up on top, do I know how many numbers are in this series? I have no clue. And so that's what I have to set out to find. Okay, so I start out with my explicit formula. My common difference, we're going up 5. And so I have 5 and then x minus 1. My starting value is minus 19. Now, like the advice I gave you earlier, let's go ahead and distribute the 5. So we get 5x minus 5 minus 19. And so ax equals 5x minus 24. Okay, I did that because this formula goes here, 5x minus 24. Now, I still have to figure out how many terms does this go out to. And so what I'm going to do is I'm going to plug in 226 into here. I need to figure out what x is. What term is this? Okay, so 226 equals 5x minus 24. Now I add 24. You get 5x equals 250. And when I divide by 5, I get that x equals, what is it, 50? Okay, that's this is the 50th term by doing that. And so I put 50 up on top. So I'm going from the first term to the 50th term. And I've written summation notation. Congrats, you've wrote it for the first time using sigma. That wasn't so bad. Okay, now we'll switch colors here just for fun. I want to do summation notation again for this one. So again, you have your sigma. We're starting at the first term. I have no idea what term I'm going to, and I have no idea my explicit equation. So let's start off with our explicit formula. The common difference, subtract 2, subtract 2. Okay, so minus 2 is my d value, and then x minus 1. My initial value is 20. All right. So first step, go ahead and distribute. Negative 2x plus 2 plus 20. And so negative 2x plus 22. This can, once we have it distributed and simplified, that can go into my notation. Okay, now I just have, all I have left is to figure out negative 26 is what term, what number term. Okay, so I'm going to start off, I'm going to plug it in, subtract 22, and I get negative 48 equals negative 2x. And when I divide by negative 2, I'm going to get that it's actually the 24th term. And so I put 24 up on top, and I have written, I have written summation notation for the series. Now, when we go to solve it, we need to ask ourselves, is the sequence arithmetic? If it is, if yes, then it's going to be linear, and we can use the sum formula that we worked with earlier, this sum formula. Okay. If it's not linear, then we literally have to write out all the terms and then just add them together. It takes a while. Okay, so this equation here is linear. The x does not have it's got a power of 1, so I know it's linear. Okay, this equation right here, it's linear because x has a power of 1. So how do I solve it? Well, I know I need to figure out my first value. Okay, so down, let's do negative 2 times 1 plus 1. That's what? Negative 1. Okay, and then up here, negative 2 times 27 plus 1. That's negative 53, I believe. Check me on that. Now I can put it into my formula. Remember our formula from back at the beginning? Okay, so my formula, the sum, how many numbers do I have in my series? 27. I know that my first term is negative 1. I know my last term is negative 53, and divided by 2. So I get 27 times negative 54. Oops, sorry, negative 54 divided by 2. And my sum, let me grab a calculator here, 27 times negative 54 divided by 2, negative 729. Okay, our last one here. I'll try to do it real quick. Oh no, it's not linear because we have an x squared. Well, in this case, we literally have to just do it all. Okay, so we have to start at 1. So 1 squared plus 5, 2, plus 2 squared plus 5, plus 3 squared plus 5. See where I'm going with this? Plus 4 squared plus 5, and then lastly, we're ending at 5, so plus 5 squared plus 5. Okay, yeah, you have to do the work. So 1 squared is 1, plus 5 is 6. 2 squared is 4, plus 5 is 9. 3 squared is 9, plus 5 is 14. 4 squared is 16, plus 5 is 21. And 5 squared is 25, plus 5 is 30. And now I just have to punch in the numbers. 6 plus 9 plus 14 plus 21 plus 30. And just make sure, yep, we're good to go. My final answer is 80. Okay, so hopefully you get a linear one, but in this case it's not linear, so I just literally have to calculate out every single term and add them together. All right, that's 9.4.